Alright guys, please flip to page 11 of your packet. In this lesson, we're going to be learning how to compare two functions, two linear functions. Just a quick reminder, please be writing down everything that I am on your packet. So we remember all linear functions are in the format y equals mx plus b. So in this lesson, we'll be comparing two rates of change or two initial values. So it depends on what the question asks. You need to make sure that you're reading carefully in order to determine which you should be looking at. Should you be looking at M or B? So they want us to compare the equation and the table. So in the equation, we can see the rate of change. The rate of change is always next to the X variable. So California recycles at a rate of 5 cents per can. Whereas Michigan, we can see in the table that every time you add one soda can, you add 10 cents. So we see that Michigan's ROC is 10 cents. Which tells us that you get 10 cents per can in Michigan. Let's flip the page. In example 2, how do we compare a table and an equation? So the first thing that we need to do is we compare the rate of change and the initial value. From the table, as you can see in the second box, we need to pick 2 points. Any 2 points will work. So they chose to pick 3, 4, and 6, -2. And so they subtract their two y values, -2 minus 4, and their two x values, 6 minus 3, to get that their ROC is -2. Whereas in the equation, we can see that the ROC is -4. So the table has a rate of change of -2 and the equation has a rate of change of -4. Let's flip the page. Alrighty, so they also want us to compare the initial value of the table and the equation. The table is kind of hard to do. The initial value we know in a table happens at 0. Unfortunately, as you can see, this table doesn't have 0 in it. So we need to figure out what would it be if 0 was there. So we need to kind of make our own table. We know our rate of change is -2. So when I'm at -1, I have 12. To go to 0, I have to go one rate of change away. I have to add one rate of change. So I'm going to subtract 2 from my x column, giving me an initial value of 10. So my initial value in the table is 10, whereas the initial value, which is much easier to find in the equation, the initial value is always the added amount at the end. The initial value in the equation is 5. So you can see in the bottom box, the question asked us to compare the table and equation. If I'm asked to compare, I need to compare the rate of change and the initial value. Oops, sorry about that. And the initial value. So the sample answer says the table has a higher rate of change than the equation. The table also has a higher initial value than the equation. They addressed both parts of a linear function. So right now, why don't you pause the video and compare this equation and table. As you can see, the rate of change of the equation is -2. The initial value is 1. From the table, If I calculate my ROC using 2 points, say I pick these 2 points, I'm going to do change in y, so -3 minus -1 over 2 minus 1. That gives me -2 over 1, which means my ROC is -2. My initial value, I have to go backwards in my table. So I want to see what would my amount in my y column be if 0 was in my x column. So what number needs to belong next to 0? The number that belongs next to 0 is 1, because when I subtract 2, 1 rate of change, from 1 I get to -1. So my initial value is 1. So a sample answer might say the two functions have the same rate of change and initial value. Notice how both things are addressed, the rate of change and the initial value. Which function has a smaller rate of change? Well, my rate of change here is 5. Notice how I go up by 1 and up by 6 in the y column. That tells me that my ROC here is 6. So the function with the smaller rate of change is function A. A grocery store has a special on apples and oranges. Do apples cost more than oranges? Explain how you found your answer. So let's check out my rate of change for apples. If I calculate my rate of change using 2 points, let's pick these 2 points. I'm going to subtract my y values and subtract my x values, giving me 3 over 5, which if you divide it is 60 cents. So apples are 60 cents each. If I check the ROC for oranges using 2 points, my change in y is 10 minus 5. My change in x is 8 minus 4. That gives me a rate of change of 5 over 4, which is $1.25. So apples cost less. Apples cost less. They have a smaller rate of change. Alrighty, so now we're comparing two taxi cabs. So AAA has a rate of change of 30 cents per mile. And they have an initial amount or an initial value of $3.25. Let's look at Joe's cab. If I pick 2 points, my ROC using those 2 points, 475 minus 4 divided by 4 minus 1 is 75 divided by 3, which is 25 cents per mile. And if we go backwards in the table, 25 cents, we can see that our initial value for Joe's cab was $3.75. So, if I want to compare the two, I want you guys to write this down at the bottom of your page. I would say that AAA has a cheaper initial value, but charges more per mile. We can see in the next problem that the rate of change for shirts are us is $5.25. So each shirt there costs $5.25, whereas at T's for You, t-shirts cost $6.25. So we can see that shirts are us is less expensive. Is less expensive. If we look at the next one, the online baseball programs cost $3.50 each, whereas Mike is selling them for $2. So Mike charges less. In the next one, we have to compare the rate of change and the initial amount. So lunch costs $2.75 per day. So that's really a negative $2.75 because you're spending that each day. The initial value is the $50 her mom puts on her lunch card each month. In her brother's account, we can see that the rate of change is $1.25, negative $1.25 because we're spending $1.25 for each lunch, and the initial value is $35. So if I were to compare the two, I would say Francine has more money on her lunch card and her meals are more expensive. Okay, the last one. So we can see in the equation that our rate of change is -4. We can see in the graph if we pick 2 points, let's say we pick this point and we pick this point, that our slope or our rate of change, we go up 8 and over 2. So our rate of change in the graph is 8 divided by 2, which is 4. We can also see that the initial value is 5 in the equation, whereas with the graph, my y-intercept, or my initial value, is 7. With the last one, my graph, if I look, I go up 2 over 1. My rate of change is 2 over 1, which is 2. In function 2, my rate of change is 2.5. So function 2 has a greater rate of change.